Alright, so this is going to be a different type of week for you because we have to get some of our assessments done in order to solidify our grades. Some of you still have to take the inequalities test. Some of you still have to take the applications tests. And some of you probably need to make up that quiz from Friday. But other than that, like I said, I'm just letting you know that we're going to be doing some quizzes over the next couple of weeks and a lot of assessment makeups over the next couple of weeks that you might want to be ready for, especially if you want your grade to go the right direction. But in terms of this work today, you've seen most of what you need for this chapter, but there are a few more topics that are on your assessments that I have to give you before we can do that. Your first assessment is going to be tomorrow. So what we're going to do is we're going to look at the work today. You're going to do a homework assignment on it. Whether you get 100 or not, whether you ask questions or not, tomorrow your assessment is on that information. And then you'll take a second one on Wednesday because we'll learn the last part of it tomorrow very briefly and then take that assessment on Wednesday. Looking at some of your grades right now, I believe that some of you have developed bad habits. Maybe you're wasting a lot of class time messing around or assuming it's easy, or maybe you're missing days and missing quizzes and not planning on how you're going to make those days up. Remember that your videos are online, which is why I do that, so that when you miss class, you can always come back, especially on quiz day, and you can do it that way. Either way, progress reports go in this Friday, and you might want to plan on making up some of those grades before then, but again, that is up to you. All that I can do is give you the grade that you earn. I will not do anything outside of that. One thing you'll see on your assessment tomorrow is something called function notation. A function is something where every input value, which we call independent variable, has one output value, which is your dependent variable. Remember that I said that this was independent because that's the easiest one to plug in for. This is dependent because that's the answer that comes out. So a function is one where every time I plug in a number for x, I get only one answer for y. Here's an example of a function right here. It's a calculator. When I type in 2 plus 2, I should get the answer of 4. If ever I typed in 2 plus 2 and it popped out of 5, or it popped out of 8, or it popped out of 3, this calculator is broken and something is wrong and you can't trust it. Now here's the thing. 2 plus 2 is 4, and that is a workable part. But 2 times 2 is also 4, and 1 plus 3 is also 4, and 5 minus 1 is also 4. So you can repeat these numbers, but the thing is, whenever you type in 5 minus 1, you have to have only one answer. Again, if 5 minus 1 gives us 2 or more answers, this calculator does not work. So a function is just one where every time I plug in for x, I'm going to get one value for y. But the difference between these two equations here is very minor. Both of them have a 3x plus 1. This one has a y equals. This one has what you would say as f of x equals. This is not f times x. Whenever you see this notation, this function notation, it is called f of x. And again, these equations represent the same thing. So whenever you see something like a f of x, or a g of x, or a p of x, or anything like that, any notation similar, the weird portion is just a fancy way of writing y. That notation is actually more efficient because in our regular writing I would have to say find the value of y equals 3x plus 1 when x equals 7. With function notation I can say f of x equals 3x plus 1, find f of 7. Notice these two are doing the same thing. Alright? The difference between this part and that part is that I turn my x into a 7, which is the function notation's way of saying simply take this 7, plug it in, get your answer. That is the value of the function. Alright? So again, all the notation is asking you to do is just plug it in and see what you get. So let's do it now. So if you have your f of x equals 3x plus 1 and they want f of 7, you simply put 3 parentheses 7 plus 1, which is 21 plus 1, or 22. What if you wanted f of 2? It means go to your f of x and put 3 parentheses, well, you're turning your x into a 2 now, plus 1, which is 6, plus 1, or 7. So f of 7 is 22, f of 2 is 7, and that is all you have to do on that. Okay, so again, when you see that function notation, it is simply asking you to take the number that is inside the parentheses and plug it in and see what you get. You are not doing any algebra or anything with the left side. You are simply plugging it in and seeing what answer you get. Another thing you're going to see tomorrow is going to talk about range and domain. You'll see problems that give you a domain and ask for a range. This is just, again, a fancy way of saying if I give you the following values of x, what are the resulting values of y? I want you to think about how easy that question would be. If I give you the following values of x to plug in, what are the answers that we get? In algebra, they'll say, if I give you, or given the following domain, what is the range? So you just have to kind of translate that. Again, domain is just a fancy word for x values. Range is a fancy word for y values. An easy way to remember which one is which is because alphabetically, x goes first, y goes second. Alphabetically, domain goes first, and range, wherever I can find it, D is before R. So again, D is first, R is second, just like X is first, Y is second. So domain is for your first letter in the ordered pair or your independent value. Range is for your dependent value. Either way, what you're going to see is a question that looks something like this. And again, it's not so bad. Just take your time. It's going to say find the range of the function for the given domain, which means find y for the given x's. And it has f of x equals 3x, and it gives me the numbers negative 3, 0, and 2. These are all x values. So what I do is I put 3 parentheses negative 3. I just plug it into here, and I get negative 9. And then I do 3 parentheses 0, and I get 0. And then I do 3 parentheses 2, and I get 6. And my range is negative 9, 0, 6. And that is all. Again, all it's asking me when it says find the range is find the possible answers whenever I plug in these numbers. So I plug in negative 3 and got negative 9, plug in 0, got 0, plug in 2, got 6. That is the range that I end up with. Okay? So other than that, like I said, it's really nothing major. You just have to make sure you hopefully wrote some of that down or study that today and make sure you get it. But notice again, all we need to do is use the domain values for x and just list your answers. Just make sure you want to understand you want to list those values in order. Most multiple choice questions don't give the numbers in a random way. That usually goes from smallest to largest. So make sure that you work on putting them in order. That way you can find them much easier. Another question you're going to see today in tomorrow's quiz is the graph a function. What I talked about was that the function is a relationship where every input only has one output value. On a graph, we have to understand what we're looking for, and so in order to deal with this, we use what we call a vertical line test. Pretty much keep in mind no duplicates are allowed for your x's. Just like I said, if you type in 2 plus 2, you're only supposed to get one answer, not 2. And so what that means is you're looking for things to duplicate, and if it duplicates, then it fails the test. So looking at the following graphs and looking only at this one, what you do is you take a vertical line, and I'm going to actually draw a real line going down that way, but you take a vertical line and you imagine that line going all the way across here. Notice that that vertical line touches once, that's good. Touches once, that's good. Touches once, touches once, touches once, touches once, touches once. So this is a function because there was no place where it failed. Remember, failing means touching it more than once. It means that you have a duplicate answer for one value of x. So again, what it is, this has no spot on there where it touches more than once, and so it passes. This one here, it doesn't have to touch all the time, so that's safe. But notice once we get right here, that touches twice, it fails the test. That is not a function. It doesn't matter how many times it touches more than once. Once you find a spot where it touches more than once, it fails, and your answer is no. Alright. Looking at the third one, it's just a bunch of points, but let's draw a vertical line through each of those points. Looking at this one, nothing touches more than once. Looking at this one, nothing more than once. Looking at that one, nothing more than once. But looking at this one, you have two spots that are right below each other. This is the reason why we can say no, it is not a function, because again, you have that duplicate value right there. And then the fourth graph, again, looking at a vertical line, passes, that passes, that passes, and that passes. So your answer is yes, it is a function. So again, you want it to only cross once. Take your vertical line. For me, it even helps to just draw a picture of it and then kind of test it with the lines until you get used to it. But again, if you find anything at all where it touches more than once, then that means that it fails the test and it is not a function. Again, you might want to write that down for yourself. That's on you, but like I said, you might want to write those notes for yourself so you can know exactly what you need to do when that vertical line test pops up tomorrow on your assessment. That actually wraps up the material that's going to be on your homework and assessment for tomorrow. For now, let's look at extending our understanding of how linear patterns work. One thing we're going to talk about also on today's homework, not on tomorrow's assessment, but just on today's homework, is rate of change. We've seen problems that ask us to find a rule for a linear pattern. In those problems, we had to look at the difference between each of the dependent values. If you remember, I gave you an x and a y, and it went 1, 2, 3, 4, and it went 7, 10, 13, 16, and you went plus 3, plus 3, plus 3, and because it was plus 3 all the way down, it was linear. My question for you is the following set of values a linear pattern? And so what we do is we look here and we see that 7 goes to 9 and you add 2. We see that 9 goes to 13 and you add 4. That's a problem. We see that 13 goes to 21 and you add 8. And based off of what we understand, the answer would be no. But let's look even closer at this, because the problems that you had were introductory level patterns. And so what that means is you notice that that goes up 1. This goes up 1. This goes up 1. 3 divided by 1 is 3. 3 divided by 1 is 3. 3 divided by 1 is 3. Notice that was your rate of change. But if you look at this one over here, this goes up 1. That goes up 2. 2 divided by 1 is 2. This, yes, it goes up 4, but 4 to 6 goes up 2, which means that 4 divided by 2 is still 2. 13 to 21 is up 8, which doesn't match, but 6 to 10 is up 4. 8 divided by 4 is still 2. So is this a linear pattern? Yes, because it's increasing by 2. And just to give you some proof, I'm going to follow the pattern from 7. 3 went to 7, 4 went to 9. If you're going up 2, 5 would be 11, but it's not there. 6 would be 13, 7 would be 14, 15, 8 would be 17, 19, 9 would be 19, 10 would be 21. Notice there's your 10, 21, there's your 6, 13, your 4, 9, your 3, 7. So the difference in where you're taking this now is, instead of having ones where the x is going only up by 1, you now have to make sure you understand that in order to find that rate of change, you have to consider how your other value is changing. So what you're going to be asked to do is to find the rate of change or slope of a table of values, and the pattern is pretty simple. All you have to do is just what we just did, which is find the difference of these two. And the way you do that is you take 41 minus 11. Remember, we take second minus first, so 41 minus 11 gives me 30. 8 minus 5, of course I don't need that, gives me a 3. And you take those two numbers and you get the answer of 10. That would be your rate of change. On this one, to get from 21 to 13, remember you do 13 minus 21, which is negative 8. To get from 7 to 11, you go up 4. Negative 8 divided by 4 is negative 2. And again, that would be your rate of change for that problem. The general rule also has a formula, and you might want to write that formula, and it looks like m equals y2 minus y1 over x2 minus x1. What that breaks down to be is just a way of helping you understand that you take the second y, it is called a subscript here. You take the second y, 41, minus the first y, 11, which is where we got our 30 from. You take your second x, which is 8, our first x, which is 5, because notice these are your x's, so second x minus first x, which gave us the 3. And then you divide those two, which is where you get your rate of change from. Keep in mind also that the m is a letter that you've seen before in the Demas equation, and remember that the m represented that number that it was changing by, and so it made it easier, it allowed us to make our equation there. So again, m is the algebraic symbol for slope or rate of change as you go on from there. What you need to do now is go to your homework and definitely get 100% on the application problem work before moving on to any homework assignments that you have not made up yet. Again, I am not giving you new homework today. Your application part has to be done though, and I'm putting that in at the end of the day. But again, this is because I want to ensure that you have seen the test questions for tomorrow before you leave. Again, I get the feeling, because some of you work out test questions as if you've never seen them, yet you spend 20 to 30 minutes a day talking and messing around with the people around you. So today I'm going to make sure that you have seen it, so that way if you don't ask about it or you don't practice it, then I'm not accountable at all for your grade. Just make sure you take advantage of your class time And be sure that your focus should be on learning the material for the quiz and the test, because what some of you still forget about is that the quiz is 40% of your grade. Your tests are 50% of your grade. And what some of you do is you rush through the homework, which represents 10% of your grade. That would be like going to the bank and stealing the pens off of the desk. You know what I mean? Like the stuff that really doesn't mean much to the bank, and you're walking out feeling like you walked off with a lot, but you really didn't do anything to hurt the bank. When you rush through your homework, you're hurting yourself, not only because you're not learning it, but you're not really doing anything to help your grade when you rush through the homework. The whole point of the homework is to get you ready for the quiz and the tests, which make up 90% of your grade. So as I said, if you do perfect homework and you do terrible on quizzes, terrible on tests, you're going to fail the class. And I need to make sure you know that, again, because progress reports go in Friday. So again, make sure you go to that work over there and get everything you can done and ask your questions, and we should be good. Good luck.